Check, check, chickadee, check, check, 1, 2, microphone check, 1. All right, boys and girls, welcome. And today in class we did solving systems of conics by graphing, and some of us struggled with our calculators and got a little mad, depending on that technology, to give us a solution. Well, today you get to solve them by hand now, and we're going to use substitution and elimination just like we did back in the day with systems, just like we did earlier in the chapter with systems of equations. All right, the only difference is now we're dealing with x squareds and y squareds. So we're going to do 2 examples together in the video, and then I got a 3rd example for you in class tomorrow that's going to blow your mind. All right, I'll bring the noise in class, but let's make sure we understand it and get the mechanics down first. So the first problem we're going to deal with is 9x squared plus 32y squared equals 324. And we have 3x squared minus y squared equals 3. Now, pretty much what we're dealing with here is an ellipse, positive, positive, and a hyperbola. And we're going to find the 4 intersection points by hand. So not by graph, but if you envision the graph, think about it. We have an ellipse and a hyperbola. So we're going to find these 4 intersection points all algebraically. But that's how you would envision it on a graph. All right, so this one, everything's lined up. We have x squares and y squares, so I'm going to use elimination. So what I'm going to do is I'm going to pick on my x squared my x squared terms. All right, and think about it. 9x squared, what's opposite of 9x squared? Negative 9x squared. So what do I need to multiply to get that to be negative 9? Well, I would have to multiply the bottom equation by negative 3. So I'm going to keep the top one the same. 9x squared plus 32y squared equals 324. And on the bottom, I'm going to multiply everything by negative 3 to get negative 9x squared plus 3y squared equals negative 9. So again, all it is elimination just like we did in the past. Then I'm going to add them up old school style and see what my result is. 9x squared plus negative 9x squared. I've eliminated my x squared terms. 32y squared plus 3y squared is 35y squared. And 324 plus negative 9 is 315. Now what I'm going to do is solve this equation for y. So divide by 35. So I'm left with y squared equals 9. Square root both sides, and y equals plus or minus 3. So I have 2 solutions. I have positive 3 and negative 3 for y. So for one variable, I have 2 separate solutions. So now what we're going to do is substitute it back in and solve. I'm just going to use this one. So I have 3x squared minus y squared, but we know y is 3. Equals 3. So all I did was substitute into this bottom equation. Now, think about this. Normally I would have to do this twice. All right, once with 3, and then again with positive 3. So again with 3x squared minus negative 3, sorry, did I just say positive 3? Squared equals 3. So I would have to do this twice with 2 solutions, but when I square this, what happens? I'm going to get the same answer either way. So we just have to keep that in mind as we're going through and solving this. So I have 3x squared minus 9 equals 3. If I did it over here, I would get the same result, because negative 3 squared gives me the same result. So 3x squared equals 12. X squared is 4. Square root both sides. X equals plus or minus 2. Now, we said we had 4 intersection points. So we have to do every combination possible. So I have positive 2 and 3, but also positive 2 would work with negative 3, because over here I would get my plus or minus 2 equal, which also means negative 2 would work with 3, and negative 2 would produce a negative 3. All right, so we did all 4 possible combinations because of this fact here. Because we have y squared and x squared, both the positive and negative solutions work. And if you think about it on our graph, all right, we would have the positive and negative, because we would have up here and down here, up here and down here. My axis would be somewhere in the middle. All right, so that's how we find them algebraically. Don't forget your plus minus, put it in, and once you put it in, it produces two more solutions. Make sure every combination is documented. All right, so that's elimination. Now let's do one where maybe elimination wouldn't work so well. All right, so number 2, I'm going to go x squared plus y squared equals 9. So we have a circle, and y minus x squared equals negative 3. Now, let me ask you this question. Would elimination work here? All right, now, if you eliminated the x squareds, it would. All right, because what happens is we would have to eliminate the x squared, though, because if you eliminate the y squared, there's no y squared down here, there's just y. So I'm going to use substitution just to show you guys the other method. However, you could line these up and eliminate. So if you want to try it that way, make sure you get the same solution. Feel free. But I'm going to do substitution. So what I'm going to do is I'm going to get x squared alone. All right, I'm going to get x squared alone. All right, so I'm going to subtract y. I'm going to get negative x squared equals negative y minus 3. And then I'm going to divide everything by negative 1. Okay, so x squared equals y plus 3. Again, you could solve for y and substitute it, and that's fine also. This is just the one I chose just because. All right, so I know x squared equals y plus 3. So what I'm going to do is I'm going to take this and I'm going to substitute it in for x squared. All right, so instead of x squared, I have y plus 3 plus y squared equals 9. Now, I'm going to rewrite this so that it's in a form that I'm familiar with. So y squared plus y plus 3 equals 9. Now, in order to solve, I need to be equal to 0. So y squared plus y minus 6 equals 0. So I need two numbers that multiply to negative 6 and add the positive 1. I got x plus 3, x minus 2 equals 0. Whoa, not x. My mistake. Y plus 3, y minus 2. So y equals negative 3 and y equals 2. So I got two solutions for my y terms. All right, so now I'm just going to take this one here because it's already solved for me for x squared. All right, and I'm going to say when y is negative 3, what does x equal? Well, when y is negative 3, what does x equal? Well, x squared equals y is negative 3 plus 3. X squared is 0. So here, square root both sides, x is 0. Well, what about when y is 2? Let me erase the arrow just so we don't get confused. So if y is 2 now, well, x squared equals 2 plus 3. So x squared equals 5. Square root both sides, x is plus or minus root 5. Right, so when y is negative 3, I get 0. So 0, negative 3 is one intersection point. When y is 2, I get positive root 5, or I get negative root 5. So those would be my three solutions for this problem here. All right, and that's how you would utilize substitution. Again, you may think it's easier to solve for y. Cool, do it that way. You may think elimination is best here. All right, your hand wasn't really forced on which method to use there, but that's how you would utilize substitution. Now, tomorrow, like I said, I'm going to bring the noise. We'll have to make some decisions on what method to use and challenge ourselves a little, and we'll be sure to go over those quizzes. So have a magnificent Monday evening, and we'll see you tomorrow. Thanks. Bye.